Have you wondered how all the wind turbine components actually get to the project area? You and I have an insatiable appetite for electricity. Come with me and we'll look at the issues relative to wind farms and the communities that they serve. This is the Windfarm Guy. Hi, this is Dennis Stout, and thank you for joining me for this episode of the Windfarm Guy. As the search for alternative energy sources continues, wind power companies enjoy significant opportunities, but they also face substantial challenges, particularly when it comes to logistics. Moving 400-foot tall wind turbines or taller is no small feat and requires considerable planning and expense. While the wind project may be good news for the wind company and the county and the landowners and ultimately for the consumers, the logistics challenges can be daunting. As an example, for one project in the Pacific Northwest, the nacelles, which is the generator housings, and hubs were brought in from Germany. Blades were transported from Little Rock, Arkansas, and the towers were shipped from Korea. The main power transformer, as well as smaller components, also come from other parts of the world. Wind companies, construction companies, and transportation companies all launch feasibility studies to evaluate the options and potential costs for moving the tower sets and components by ship, truck, rail, and barge. While trucking can be the most obvious choice, the size of the wind turbine components presents a significant challenge. The trucking industry's fragmented regulatory system complicates matters. Current rules allow individual states to determine the routes oversized trailers must take, which often means longer trips, resulting in slower delivery times and higher costs. Scheduling the required highway patrol escorts is also an issue. If moved by truck, each three-section tower, consisting of base, middle, and top pieces, needs an escort. The nacelles, blades, hubs, and internal equipment would require additional trailers and escorts as well. Therefore, each turbine requires at least 8 separate trucks. Coordinating drivers, escorts, permits, and specialized equipment to move all the parts is a monumental and costly task. Sometimes those costs include storing the components while waiting for a logistic bottleneck to dissipate. The companies consider all their options because moving oversized loads from state to state is complex. The special trailers some states mandate won't necessarily meet other states' requirements. Moving the towers by truck is expensive and complicated because moving wind energy equipment requires special considerations. Every state has multiple regulatory requirements and turbines are continually increasing in size. Transportation companies frequently compare transportation restrictions to the size of the towers being built and incorporate new trailer designs for those components. Those trailers can be so specific only for that turbine in that particular state that they sometimes will not have another use. Interestingly, barges triple the speed of transporting the components and eliminate the bottleneck of having to schedule highway escorts. But barges won't work just anywhere. In fact, they won't work in most of America. But where they work, they rule. Rail is another way in which turbine components can be transported, but rail comes with its own set of logistic complexities. But no matter how the components are shipped, that last leg is done by trucks. If you like what I've said today, be sure and click like and subscribe below. If you have thoughts or want me to address a particular topic relative to wind farms, please also leave me a comment. The logistics of gathering wind farm components to the project area is a massive undertaking. Whether the large distances are accomplished by ship, barge, rail, or truck, the final step of getting the pieces to the individual turbine locations will be done by a truck. A construction company will then go to work erecting the towers, connecting the nacelles, hubs, and blades, and taking the project online. There's a whole army of brilliant people making this happen quickly and safely. This is Dennis Stout, and I'm the Windfarm Guy. Thank you for watching. Working together, we can make good energy decisions and save our planet. I am the Windfarm Guy.